Alright, we've been locked down and watching some videos for a few days, so then I found my sheriff hat. Give you a little chuckle this morning. Or this afternoon, I guess. Well, for me it's morning right now, so whatever time you're getting around to this. Here's the idea today. We're going to identify if something is linear, quadratic, okay, so linear, this is x to the first power, quadratic, x squared, or exponential means that we have some base number and we're going to take it to the x power. So we're going to really focus on identifying what it is and not so much on writing the equation, except for linear, because you can already do that. So when we get to linear ones, we're definitely going to do that, and that should be reviewed. So we have a constant, right? That's the slope, and we find that by taking the difference. Remember the equation for slope? Y minus y over x minus x. Okay, so y2, y1, x2, x1. Okay, this quadratic, this is kind of where we're at. This is a little bit tangent for just a little bit of time, so we don't have to think about it. And this is taking the difference of the y values. And then in our exponential, we'll find out that it's exponential either 1 by the graph or 2 by having a common ratio. A ratio is something like 2 over 3. So that means we're looking for a fraction. Okay, so we should be looking to divide to find out exactly what that common ratio is. So that's what we're going to work on. Let's take a look at how it works. So first thing is plot some points. 0, 0. Got it. 1, 1. Negative 1 with negative 1/2. Okay. And 2 with 3. Alright. So what do you got here? They don't exactly line up, right? Because this guy right here threw me for a loop. So it's definitely not linear. And quadratic, just not exactly sure there. So what we're going to start thinking about is, can we get to that exponential? So we're going to circle which one seems most appropriate. Alright, so this one we're a little bit lost. We're kind of stuck in between. So what we're going to do is we're going to go to the next slide. And the sheriff will show you how we do this algebraically. But we definitely know it's not linear. So we're stuck between these two. And we'll find out exactly how to tell which one it is. Alright, to do that, we're going to use differences or ratios. So what we're going to do is check these out. We're going to plot some numbers in here. So we're going to take all of our ordered pairs, put them into our table. Now luckily these are already in order. 2, 4, 3, 8. Alright, so from 1/2 or 0.5 to 1, that's an increase of 0.5. Then we're going to go up 1. From 2 to 4, we're going to go up 2. And from 4 to 8, we're going to go up 4. So this would be linear, or x to the first power. So that's no good, right? Because these numbers are different. So what we'll do is we'll check round 2. When we check round 2, this is going to go up by 1/2. This one goes up by 1, and this one goes up by 2. This would be a check for quadratic. It didn't work. Okay, so the last thing we have to do is work backwards. So we're going to take and say 1 divided by 0.5 is 2. 2 divided by 1 is 2. 4 divided by 2 is 2. So I'm working backwards this table over here. 8 divided by 4 is 2. And what that means, since we're able to find the same ratio, we're dividing over here. Everything on the red side, this was subtracting, find the difference. Now we're talking about ratios. So this is an exponential function. So let's go back to the last one. We weren't sure. So let's just take a look at our values here. We're going to go up by 1. And these are out of order. But this change here was 1/2. Okay, so linear was out. And then from here we were at 2. So here's what I have. If I put it in a proper order, we had negative 1/2, went to 0, went to 1, went to 3. So I had 1/2, 1, 2. So this is linear. We crossed that one out. We had that one already. Next thing we'll check is 1/2 and then 1. So this was quadratic or x squared. It's no good. So it must be exponential. Okay, those are only 3 choices, so it has to be exponential. Now, there's a chance that it's something other than that, but right now we're not going to do that. We're trying to take care of that for you. Right. So by the graph, we can definitely rule out our linear. If this would start coming back up, we'd know that it's quadratic. But if it doesn't, then we might have to use some algebra to figure it out. And that's okay, and this is how we do it. Alright, so this slide here, we basically covered everything that we need to go over, other than graphing points, and you know how to do that. Okay, so here's what we have going on. So if we take a look at the graph, which one do you think it is? Well, it sure doesn't look like it's headed back up anytime soon. So I'm thinking it's exponential. Alright, but I want to check algebraically. So I'm going to check all these numbers, and I have that on the next slide. That way we don't have to retype everything. So here's what we have. 6 over 30 is 1/5, which is 0.2. Well, 12 divided by 6 would be 2, but I have to move the decimal point over, so it's 0.2 again. I'm starting to see a trend here. 24 over 12, it would be 2, move the decimal over, 0.2, and 0.2. So all these numbers are the same, so it does make it exponential, because we found a common ratio. If I had 0.2, 0.3, 0.4, it wouldn't be none of these things, and that would probably fall into one of your Algebra 2 classes. Alright, so now we have kind of two options, whichever way you want to deal with it. Obviously the first thing is, if we can graph it and see exactly what's happening, that makes it super duper easy. So 1, 3, 1, 3, here you go. 0, 0, negative 3 with 3. Okay, so I start to see a loop in here, so I'm thinking it's going to be quadratic. Negative 1 with negative 1, and negative 2 with 0. Alright, there it is. Okay, so we can make the assumption that's what it is. So this is x squared, which is quadratic. And now remember, the only thing that I'm asking for equations for is linear, because we've done that already. Alright, so here it is just in a table. By all means, if you want to make a graph, start doing that, but we'll check this out. We're going to go down 4, and down 4, and down 4, and down 4. Alright, so we found it from the difference. This was the first time through, so it's linear. And what we found is, each time it changed by negative 4. So this is what we know so far. We just don't know what b is. So let's take a quick look. See, did they tell us that at all? Remember, b is the y-intercept. So I'm looking where x is 0. Ooh, there it is. Ooh, there it is. You remember that, right? Okay, so y equals negative 4x, and they already told me we get negative 3. If not, we're going to plug in an ordered pair for x and y and solve for that b value, or you could use point slope form from way back. That's totally 2019. Alright, so we want to identify which one it is. We want to write it if it's linear, but let's take a look here. We got 1/2. I got 1 and 1/2. Okay, so we're not going to write it because this isn't linear. We'll do more of that in Algebra 2. This is 2.5, and this is 3.5. So linear is a big no. Or as you guys know I like to say sometimes, nah. Alright, so we got 1, we got 1, and we got 1, right? 1/2 to 1 and 1/2 is an increase of 1. So this is quadratic, or an x squared. But we're not worried about writing those equations just yet. This is checking first difference, second difference. If I didn't get that, I would work on dividing them. Alright, so I have one to check out here. We're going to plot these on here. We need a small theater company. Plot some points, see what happens here. And we get real world data, which means it might not exactly line up. But I just want to see what trend it makes. So 0 with 18,254. And I'm going to get a lot of these pop up as we try and get some of these screens on. 1. Okay, so now I'm almost halfway. Here 2. We're a little bit more than halfway on there. All the space, we could have used, something a little different breakdown, huh? Year 3. we're looks like about 3/4 of the way, and year 4 is going to be just over that 20 mark. Alright, I don't know about you, but that surely looks like it lines up pretty well. So I'm going to call that linear. And notice, just to try and make sure we had all these things, we had circular. That's not even a choice for us right now in Algebra 1. But they felt like they had to have 4 choices. I can't blame them. Alright, so if we take a look at those, they do line up. Gotta get a line tool over here. Drop this thing down just a little bit. Maybe put a yellow line on here, see what happens. See, they do line up pretty well. Even though they're not exact, if we checked it by algebra, we're going to find out from the graph, talking about real world data, it's not perfect, but that's the model we would use. Alright, so a quick little explanation. How can you decide? Okay, so maybe in one sense you talk about the graph. What are you looking for? And in the other one, on the table, how do we know? So a quick little reflection, think about what's going on with this idea today. And then of course, thoughts, comments, questions, what do you have? Put those in your Pear Deck. Or what would you like to add to the picture? Nice little picture, beautiful parabola, a little stormy day. I like what's going on with the clouds over here. Looks pretty nice. You see the city in the background. Either way, I'll turn this off so you can get to work. Alright, have a great day.